We are all familiar with how water behaves as the temperature changes. Between 0 and 100 degrees Celsius, it's the familiar clear liquid. Raise the temperature to 100 degrees and it turns to vapor in the form of steam. And if we lower its temperature below 0, it becomes solid as ice. This is all very familiar at normal atmospheric pressure. But if we look at the effect of changing pressure as well as temperature, some interesting things happen. As the pressure decreases, the temperature at which water changes from liquid to vapor also decreases. If you lower the pressure enough, water will become vapor at normal room temperature. And if you lower the pressure to less than 6 millibars, water won't stay in liquid form at all. Instead, it will change from ice to vapor, or vice versa, without ever being in liquid form. The point where this first happens is known as the triple point. So, as long as we keep the pressure and temperature below the triple point, water can be extracted from frozen product as vapor only. This process is known as sublimation and is the key to successful freeze drying. The unique way that water behaves can be demonstrated by putting a glass of water into the freeze-dry chamber and lowering the pressure. At about 1/10 atmosphere, the water reaches its vapor point and appears to start boiling, even though it's still quite cool. If the pressure is further lowered to below the triple point, the water freezes to ice. As long as the pressure and temperature stay below the triple point, the solid ice will sublimate directly to vapor, eventually migrating to the condenser unit. So, maintaining the correct relationship between temperature and pressure over a complete drying cycle is essential for effective freeze drying.